we are going to factor higher degree polynomials to find zeros and roots. So up until this point, the highest exponent you guys have seen was x to the third power. And when you would see x to the third, usually it was like a grouping method that we would do. But more often than not, you know, the highest one we've seen were like quadratics, where at most you guys would find 2 answers. Sometimes on the ones to the third power where we would do grouping, you guys would get 3 answers. Today you guys might see some exponents higher than 3. Okay, and that just means that you have potential, like if the highest exponent is a 5, potentially you could have 5 possible x-intercepts. Okay, so real quick, right here it says quick review, determine the zeros of a polynomial from factored form. So this example right here, they've already factored it for us. So that makes this one way too simple, but this is just a review. So most of you could go ahead and tell me what these 2 answers would be. Like this one would be x equals what? -1. This one here would be x equals +7. This one right here is the only one that we'll probably have to like show work for because it's a 2-step. So we would take the 3x minus 2, we'd set it equal to 0, and then we would solve that. So how do I solve that? Add 2. 3x equals 2, and then what? Divide by 3. Yep. So I left my answer there as 2/3. That's the same thing as 0.6 repeating. Either way you write it is fine by me. But this was that easy because it had already been factored for us. And there were 3 sets of parentheses, and you guys are used to seeing no more than 2 sets. But that problem there had 3 roots, which means if I were to actually graph this, it would cross the x-axis in all 3 spots. It would cross at -1, it would cross at 2/3, and it would cross at 7. So it wouldn't just be like a parabola that crosses at 2 places. It would be something like, okay, here's your x and y axis. It might cross at -1, cross at 2/3, and then cross over here at 7. You know, it might be a graph that looks like that. This would have 3 solutions because it crosses in 3 different places. Okay, now you guys aren't going to have to graph any of these today or anything like that. We're going to just focus on, here's a polynomial that has not been factored. We need to factor it so that way we can find our solutions. Okay, so first question you would always ask yourself, do these 3 terms have anything in common? What do they have in common? To the what power? X to the third. So x to the third power is their GCF. So we're going to pull that out. And in parentheses, you guys are going to tell me what would be left over out of all that. X squared minus 10x plus 25. And anytime we're trying to find our roots or our zeros, you just set the whole thing equal to 0. Okay, so now isn't this in here a quadratic that we can factor using the asterisk? Okay, so let's do that. We've got positive 25 up top, negative 10 at the bottom. And what would we get for 2 numbers that multiply to give us 25 and add to give us negative 10? Yep. Both of them are negative 5. Okay, so now you might want to look up at the board real quick. When I rewrite this in factored form, this x to the third is still there. Like you can't get rid of that. That's still there. And then my 2 sets of parentheses are x minus 5. Okay, so what you guys are used to seeing, okay, We'd set this equal to 0, we'd solve it. We'd set this equal to 0, we'd solve it. And out front, up to this point, you guys have only had numbers here like a 2. The 2 never mattered. So whatever the GCF was, if it was just a number, it didn't affect our 2 answers. This is not a number though, this is a letter. So I'm going to have to set whatever is out front equal to 0 as well. Okay? So we are going to get one answer here, one answer here, one answer here. Now these two are both going to give me the same answer, won't they? These are both going to give me x equals what? Positive 5. Now the x to the third, if I set x to the third equal to 0, what is the only number times itself 2 times, 3 times, 4 times that's going to equal 0? The only number times itself is 0. So x is equal to 0. So didn't we just have 2 solutions? But, look up here, because the highest exponent was a 5, we could have had a possible 5 solutions. Whatever the highest exponent is, that's how many possible solutions there are. It just so happened that when we factored everything out, we really only had 2 solutions. So it still would only cross at the 0 and the 5. All right, are you guys good with what I just did there? Factoring out what they had in common and then doing an asterisk problem? All right, go ahead and turn the page. Okay. All right, so now we're going to do some more examples here. We have x to the third plus 9x squared plus 18x equals 0. Okay, do they have anything in common? What do they have in common? So we're going to factor out the letter x, and then in parentheses, let's put what would be left over. So instead of x cubed, we have x squared. Instead of 9x squared, we have 9x, and instead of 18x, we just have the 18. Now this is 3 terms, so that's an asterisk, right? With an 18 and a 9, which we've actually already factored that today. What do you guys think? Yep. 6 and 3. So we have the x just comes straight down. That's left out front. And then we have x plus 3 and x plus 6. So this one and this one would be, if we set this equal to 0, x would equal what? This one. And then if I set x plus 6 equal to 0, x would equal negative 6. Now the x out front, whatever is out front, you just set equal to 0. Well, wouldn't that just say x equals 0? Yep. Okay, so if you look back at the original problem, the highest exponent was a 3, which means there are 3 possible solutions, and we just got 3 solutions to our problem. So that makes it. That's all we're doing. Yep. So it's just factoring. It's factoring out the GCF and then using the asterisk. Okay? It's just you guys haven't seen a lot of x equals 0s. You've been seeing these two. You just haven't had anything out front. Well, now you're probably going to have something out front, which just gives you a third possible answer. Okay? Now this one down here, the x cubed minus 36x equals 0. What do those two terms have in common? I will, give me just a second. And then what would be left over on the inside? Yep. Okay, so just think about it. If you guys have x squared minus 36 in that set of parentheses, there's only two terms, right? They're separated by a minus sign. It's a difference of squares problem. So instead of doing an asterisk on this, this is just difference of squares. So I'm going to leave the x out front. That doesn't change. But when we factor x squared minus 36 using difference of squares, what would it become? Good. X plus 6 and x minus 6. Remember, all you guys are essentially doing is just taking the square root of each term, so x and 6, and then making one set of parentheses a positive, the other one a negative. And then we can go to our three answers. This one's going to be x equals 0. This one's going to be x equals, and then the last one, x equals positive 6. So the original problem had the highest exponent of 3, meaning you might get 3 possible answers, and we just got 3 solutions. All right, now look at this last one. This one says, let's factor by grouping, because if you look up here, do all 4 terms have anything in common? All 4 terms? No. So if all of them don't have anything in common, we can't just do GCF and then an asterisk. We need to group. And it's been a while since we've done grouping. So let's go back through these steps. Okay, so look up here. These first 2 we're going to do GCF with. So what do x cubed and 3x squared have in common? X squared. Then in parentheses we would have what? Yep. X minus 3. Okay, then, again, you might want to look up at the board. Then we just kind of shift over. We ignore the first 2 sets of parentheses, or the first set of parentheses, and now we're looking over here. We're looking at these 2 terms. What do x and 3 have in common? Well, you say nothing, but everything has what number in common? 1. So we can just, if this is a minus sign, we're going to put a minus, and then we can say that they have a 1 in common. So then in parentheses, when you guys go to do your division, we're not just dividing by 1, we're dividing by negative 1. So what is a negative x divided by negative 1? Negative divided by negative is positive 1x. And then what's positive 3 divided by negative 1? Negative 3. And if you have already forgotten about grouping, when you group and factor, these 2 right here should always be identical. If they're not, then you did something wrong. Okay? Now to go to your 2 sets of parentheses, do you remember how to do that? How do I write all of this in just 2 sets of parentheses? So the x squared minus 1 goes in one set, and then whatever one they had in common, the x minus 3 goes in the other. Good job. Okay, now I know you guys can do this one in your head. If you were to set x minus 3 equal to 0, what would x be? Positive 3. This one over here, I'm going to require you guys to show because it has a squared in it. That's going to make something a little different here at the end. Okay, so I'm going to set x squared minus 1 equal to 0. And then how would I solve that? Add 1. So you have x squared equals 1. And how do you undo squaring something? You take the, what? Square root. So we're going to take the square root of each side. What's the square root of 1? 1. Okay, now here's the thing. If you were to type into your calculator, square root of 1, doesn't the calculator only give you positive answers? Because 1 times 1 would stay 1. But what's negative 1 times negative 1?
0.
What's a negative times a negative?
Positive.
It would be positive 1, wouldn't it? So if I say what's the square root of 1, couldn't it be positive or negative? You guys remember when we did quadratic formula? Remember how there was always that plus minus sign in front of the radical? That's because square roots can be positive or negative. Typically, we only talk about the positive ones because when we type it into a calculator, that's what they give us. But in all reality, if we're just looking for the number times itself to give me this, it could be positive 1 times positive 1, but it could also be negative 1 times negative 1. So whenever you guys have a problem where you have to take the square root, you need to make sure when you write your final answer that you remember to put that plus minus symbol there. Because look, that's 1 answer, 2 answers, 3 answers. You now have 3 answers written down here. If you had just put 1 and 3, you're missing one of your solutions. Okay? All right. How's that so far? Is that okay? All right. So now this is going to be some new stuff coming up next. The ones that we're going to work on next, it's something called the rational root theorem, okay? What this rational root theorem does is it gives us a list of possible solutions to polynomial functions, okay? So, meaning you might be given a polynomial that looks like this, and do all 4 terms have anything in common? No. Can I group this? I mean, I could try, but these two do not have, like if I were to say these two had x squared in common, just watch. If I said x squared is what they had in common, that's what it would leave on the inside. And then if I do GCF over here, look at what I would get. Do these two sets of parentheses match? No, so I mean I can't use grouping there either. So we had to find some other kind of method to be able to figure out, okay, what are all my possible solutions? And then we're actually going to figure out what the real solutions are. So to find the possible solutions, you guys need to pay attention to this because this is stuff you've probably never seen before. What we are going to do is we are going to set up a fraction here. The P are all the factors of the constant. So here's our constant right here, the 4 at the end. That is our P. Tell me the numbers that are factors of 4. Like numbers that you know go into 4. 2, what else? 4 and what else? 1. Okay, so look, we have positive and negative 1, because they're all going to have plus or minus with them. We have a positive and negative 2, and we have a positive and negative 4. Those are all the factors of 4. So factors of the constant go up top. Then on the bottom, they call it Q. Q represents the factors of the leading coefficient. Well, the leading coefficient is the number that's up front, the 3. This is Q right there. Okay, so tell me factors of 3, starting with, we're going to put the 1 first. What's the only other number that goes into 3? 3. So plus or minus 3. Okay? So factors of the constant, factors of the leading coefficient, and then here are all our possible solutions. Are you guys ready? Let me write it first so you guys can watch the explanation and then you can write all your answers because there's a lot of them. It could be like these two divided by each other, so positive or negative 1, because 1 divided by 1 is 1, right? Okay, then I'm going to pair up my 1 and my 3. 1 over 3, isn't that 1/3? So I could have positive or negative 1/3. So I've dealt with the 1s. Now I'm going to move over to the 2. What's 2 divided by 1? Positive or negative 2. And then 2 over 3 would be 2/3, right? So positive or negative 2/3. And then let's do the 4. Now 4 divided by 1, positive or negative 4. And then 4 over 3, wouldn't that just be 4/3? So positive or negative 4/3. I mean, just look at how many possible solutions there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 possible roots, supposedly. Now, that doesn't mean that they all work. They're just saying if we set it up this way, there's a possibility that we could have 12 different answers. Now, there's not going to be. We have to figure out which of those are the true solutions to the problem. So turn the page and we're going to show you how to do this. Oh, sorry. Does everybody have that written down? Let me know, Caleb. I know, it's a long Monday. I'm sorry. Remember that synthetic division lesson we did last week? We're about to do something synthetic division, okay? Go ahead and turn the page. Remember our first two possible ones were positive 1 and negative 1? Those are the two numbers we're going to use, okay? We're going to use those with synthetic division. So in order to find the actual roots, this is what you guys are going to do. How many terms do you see here? Okay, so when we do synthetic division, remember how we would set up, we always set up 3 rows, and then the number of columns was based on how many terms we had? Okay, so we're going to split this into 4 columns. We're going to write our numbers up there. We have 3, negative 5, negative 4, and positive 4. And I told you, we're going to try positive and negative 1. So we're going to start with the positive 1 out here. First number drops straight down. And then do you guys remember how to get all these boxes filled in? And put it here. Then you add going up and down. So negative 5 plus 3 is negative 2. Then we multiply the bottom number by the 1, which is negative 2. And then you add going up and down. Negative 6. What we're looking for is this. We are looking for the number out here that will make our remainder 0. That's what we're looking for. 1 times negative 6 is negative 6. Is our remainder going to be 0? Okay, so since this remainder is not 0, 1 is not a solution. So we're going to just cross this out, and instead we're going to try the negative 1. So I know you got to set up another, set this up again. So 3, negative 5, negative 4, and 4. And then this time we're going to use a negative 1 out here instead. Okay. Okay, so what do you guys think? What is negative 1 times 3? Negative 3. And when you add those going up and down, we get negative 8. And then we take negative 8 times negative 1, which is positive 8. And what's negative 4 plus 8? Yeah, sorry. And then 4 times negative 1, and now we have a remainder of 0, right? Okay, so negative 1 is one of our actual roots. One of those will work. Either the positive 1 or the negative 1, okay? They should. Now, to get your other answers, do you guys remember how we would write this out here? We'd put 3, and then instead of x cubed, it would be x what? Okay, and then we just worked our way down, right? So 3x squared minus 8x plus 4. And if we set that equal to 0, now we can do an asterisk, because now we have a quadratic. This will allow us to get our last 2 answers. So nothing we're doing is really all that complicated. We just did synthetic division twice. We wrote our answer from this one, and now we're just going to factor like we always have. So what number goes up top? Yep, 3 times 4 is 12, negative 8 at the bottom, and now both of these are 3x's instead of 1x's. What are my 2 factors? Negative 2, negative 6. This one right here, you guys probably want to look at the board. This one will not reduce, right? The 3x minus 2. The other one will. What will this reduce to? 1x minus 2. Yep. Okay, so now all we have to do is solve these 2. So this one, I think you guys can just go straight to your answer. What is that one? Positive 2. It's this middle one. Well, middle, it's not really in the middle. It's this one. The 3x minus 2 you'd actually have to work out. How would I solve that? No. You'd add 2. So 3x equals 2, and then divide by what? Yep, so x is 2/3. So positive 2/3 was another answer, and so was positive 2. So out of the 12 possible solutions, there were actually only 3 that work. And if you look back at your list that we made on the previous page, all 3 of these numbers were possibilities. We just had to figure out which ones actually worked. What do you guys think? Is that okay? Maybe? Ish? Well, good news. We're going to practice 2 more together. Okay, so let's take a look at the bottom. We need all the factors of the constant first. So what numbers go into 2? What are factors of 2? Just give me the numbers. 2 and 1, right? So we have positive and negative 1, and we have positive and negative 2. Those are the possible factors of the constant. Now on the bottom, we put the possible factors of 15. Now there's more for 15. We've got positive and negative 1. What else? Positive and negative 3. Keep going. Positive, negative 5, and then what's the last one? 15. So this was P divided by Q right here. So these are the factors of the constant divided by the factors of the leading coefficient. So let's talk about all of our possibilities. Are you ready? Because I'm actually just going to go straight down here because we were going to have a lot of them. So look, 1 divided by 1. Okay, so we've got positive and negative 1. Okay, now I like to just do the ones first. So like what I'm doing is I'm ignoring the 2 up top, and I'm just pairing up the 1 and the 1, the 1 to the 3, the 1 to the 5, the 1 to the 15. So wouldn't all of these be fractions? 1/3, 1/5, 1/15? And you can have the positive or negative of each. Okay, so we've got all those. Now I'm going to go through and I'm going to do the 2. So I ignore this 1 because we've already done all those. What's 2 over 1?
2.
And then won't the rest of them be fractions? You'd have 2/3, 2/5, 2/15. So positive, negative 2/3. That was ugly. Positive, negative 2/5. And then positive, negative 2/15. There are lots of options there. We've got 2, 4, 6, 8, 10, 12, 14, 15, or 16. I couldn't count, apparently. 16 possible rational solutions. Never going to be that many for actual. Okay, but we're going to make our list of possible, flip it over, and we're going to do this same process we did up here. We're going to do synthetic division using a positive 1. If that does not give us a remainder of 0, then we're going to try negative 1, and that one should work. Okay? Caleb, you got those? I'm going to probably have to go on, and then I'll give you my copy to get that finished. Okay? Because I want to finish this one so that way I can stop the video and then I'll let you get caught up there. Okay, so back here, we've got 4 terms again. So we're going to do 4 columns, 3 rows. This is good stuff. So we've got 15, 14, negative 3, and negative 2, and we're going to use positive 1 first. Maybe we'll luck out. Maybe the 15 will work. I mean, the 1 will work, and then we won't have to do the negative 1. Maybe. Okay, so 1 times 15. 14 plus 15. 29 times 1, and then negative 3 plus 29 is 26. Well, I'm guessing you guys can already tell this isn't going to work, right? 26 times 1 is 26. That is not a remainder of 0. So that one's out. So let's do negative 1 instead. All right, now 15 times negative 1 is negative 15. 14 minus 15 is negative 1. Negative 1 times negative 1 is positive 1. And negative 3 plus 1 is negative 2. And negative 2 times negative 1 is positive 2, giving us a remainder of 0. Found it. So if we were to write this using this bottom row as our new quadratic, it would be 15x squared, because we always drop 1 from the original, then minus 1x minus 2. And now we have a quadratic that we can factor using an asterisk. So Hannah, the lesson over synthetic division is a lot of this. It's really not that complicated, but the synthetic division problems, you're gonna have to figure out how to get this number, and that's in the video. Well, you watched the video, but yeah. Okay, so when we do the asterisk, we've got 15 times negative 2 for the top, that's negative 30, and a negative 1 at the bottom. Oh yeah, gotta make sure I include negative 1 as one of my answers. Don't forget that. Okay, what are the two factors over here? Negative 6, positive 5. Yep. This one right here will not reduce, so I have 15x minus 6. Now the other side does. 15 and 5. Oh wait, 15 and 6 reduce too. Crap. Hang on, where's my whiteout? 15 and 6 are both divisible by what? 3. Sorry about that. We'll just fix this real quick. So this would be a 5x and a minus 2. 5x minus 2. It just makes it smaller. Makes them easier to solve. The 15x and the 5 both divisible by 5, right?
Yeah.
So 3x plus 1. Alrighty. Now both of those are 2 steps each. So I would work them both out, because they're both going to be fractions. They're not ones that you can just quickly do in your head. I'd add 2, giving me 5x equals 2, and then I would divide by 5. So it looks like one of our answers is the positive 2/5, and then the other one, I'd subtract 1 and divide by 3. So it looks like our last one is negative 1/3. So you've got negative 1, negative 1/3, and 2/5. Those are your actual roots to the problem. Woohoo! All right, that is the end of your notes. And then I'm going to give you guys a practice page. It is already 3:15, but I'm going to hand that out in just a minute. Let me get this video stopped.